Okay, welcome back. Um, this is the last part of this unit. We're kind of wrapping things up. This unit hasn't been as long or as intense as the other ones. And these different kinds of reactions are classified. So they're classified by what happens to the reactants and what happens to the products. So this is the reaction. This is an example of the reaction where we have the hydrogen plus the oxygen make just one thing on the right, make the water. When this comes together and more complicated things make us, simpler things make a more complicated thing, and there's one new substance, this is called synthesis, like photosynthesis, for example. So on the left side, we have two or more things. We have hydrogen and oxygen. On the right, we have just one. And that's one of the ways you can tell if it's a synthesis reaction, if there's only one product, like this H2O. There's only one formula over here. Now, when Bill and I ran the electricity through the water and broke it apart into the hydrogen and oxygen, just like last year when you learned, the tree dies in the woods, and then it breaks it apart, that's called decomposition. So when there's one substance on the left side, one reactant, and two or more on the right, it's decomposing. It's breaking down this whole thing, like the tree, into the different parts, okay, like in decomposition. So we start off with one thing on the left, and we end up with more than one thing on the right. So these two are like exactly the opposite. And that's what we looked at with the endothermic and the exothermic reactions. Okay. Then there's single replacement. That means one thing is replaced. That's why it's called single. This is one element replaces another. So I'm going to highlight the lithium and the iron. Okay, and so the iron you can see is in this compound with the bromine. And the lithium is over here by itself. The lithium is going to go and take the iron's place. It's going to replace it in that formula. And the iron is going to get kicked out. And you see over here in the products, the iron is alone. Okay? And look, see the lithium moved in there, and now it's in the compound with the bromine. There was one replacement. This element, the iron, got replaced by the lithium, and so the iron's kicked out. So one of the ways you can tell a single replacement is you look and see there's one element replaced. And look, these two were always single elements. Okay, so you have a single and a compound and a single. And this last kind of reaction is double replacement. So I put in here in the description, two compounds are reactants and two compounds are the products. One element from each side is switched. So you see we have a compound, this silver nitrate and this potassium chloride, and we have this silver chloride and the potassium nitrate. So two of them are going to switch places. Up here, only one switch place. The iron switch place with the lithium. Okay, so over here, we're going to see that the silver is going to go take the place of the potassium. I'm going to highlight the silver here with the blue. And when we look in the product, it's here with the chlorine like the potassium was. Potassium's been replaced by the silver. That's one of the replacements. You see? It was potassium chloride here, and over here is silver chloride. Now, the potassium is going to move in and go where the silver was. That's the second replacement. I highlighted the potassium. We can see that it was with the chlorine, but over here, it's with the NO3. So it took the place of the silver. So both of these switched places. There were two replacements. The silver took the place of the potassium, and the potassium took the place of the silver. And then the last thing is the formation of a precipitate. Sometimes when these reactions happen, they make a solid, and then the solid settles out at the bottom of the reaction, and that's called a precipitate. Like rain is precipitate.
Now, precipitate is when a solid comes out of the solution, because we're going to do a double replacement, or something called a metathesis reaction. Lead plus 2 from this beaker is going to attract and hook up with the iodine ion to make PbI2, or lead 2 iodide. And that is going to create a precipitate, because the lead iodine prefers itself more, or attracts itself more, than water. So let's do that. Here we go. Very brilliant reaction. And you see that as pretty, very pretty yellow precipitates. So there you go, and there's your precipitate. And it's a precipitate because I know that I cannot see through the solution anymore. And if we let this settle for a while, we'll get something like this. This is a reaction I did about an hour or so ago, and you can see here that the clear solution is the potassium nitrate ions, or the potassium and nitrate ions, and the solids are at the bottom. That's settled at the bottom. All right? So there is your precipitating reaction.
Okay, and then I'd like you to take a look at these questions on your own, and then pause the video and come back and we'll go over these answers. When one substance breaks apart, it's called a decomposition reaction. The key word here is it's broken apart. When two or more substances combine to make a single new substance, is called synthesis. When a single element replaces an element in a compound, so we have single, it is called single replacement. When two compounds switch elements, it's called double replacement. And that solid, like we saw, the yellow stuff that's settled out at the bottom, is called a precipitate. And then next time we're going to pick up with solutions. Have a great day, and we'll see you next time.